So last night I was working on this refactor, right, and I got most of it done. This morning I kind of had an epiphany about a change I'd made in the atmosphere code that was leading to when you got close to the surface of the planet, you would see like a little circular ring expanding out as you got close to the surface. So I actually had an epiphany that I had changed the skylight method as a part of the refactor. I changed it back. So instead of passing scene depth here, passing atmosphere radius times 3 like it originally was. That fixed the issue with getting close to the planet and having that circle appear. You can see it's like a completely smooth transition with no like visible artifacting or anything now, which is really nice. That means our atmosphere shader is done with no more bugs. And I refactored the rendering pipeline last night to basically be controlled by the nodes rather than the parent wrapper. So each node is responsible for rendering its own chunk. And I think we've done a pretty good job here. We're getting pretty good performance at this point. Fast chunk loading, everything runs really well at in like the actual speeds that you would be playing the game at. So like we'll just go like here maybe. Shaboom. And then we fly down and we shouldn't see any obvious stuttering or lag anymore. Now, I would see it if I increased the resolution. There's something about there's something about the LOD function I'm using that is not deprioritizing closer LODs enough. So if I turn up the LOD division depth too high, then when you get super close to the planet, it will just like fill. Like you won't have multiple LODs, you just have like the highest LOD and then maybe like a couple other LODs and then the others, but it's like the highest LOD is overlapping existing LOD levels. Um, so I might mess around with the LOD function today and see if I can find a way to like make the higher LOD levels require you to be closer or something like that. Because I would really like to be able to run this on like an 11 or 12 depth, but have it only like a very limited space that we load that detail in, so that if you were to land on the planet and walk around on it, you would have like full detail. Because like, and honestly, it doesn't really even need to be that way in the ship. Like you could dynamically adjust that depth when the player gets out of the ship to turn the WOD way up, and that might be the way to do it. But you can see here we've got a really nice atmosphere shader. Um, we've got nice distance fogging that's like consistent with the lighting from the atmosphere. We're getting, oops, the fuck? We're getting good time, good speed on our uh, mesh loading as well. So now I have a bunch of dead code basically, and my favorite thing to do is deleting code. It means we have a better way to do it, less complicated, better in general. So now we're just gonna like double check our planet actor and quadtree node classes, and we're gonna make sure that everything is good. think it makes sense to do a destroy on all our chunks here before setting them to null. There we go. Oh, I was already setting this, huh? Okay. Initialize planets. I'm really happy with this because it's made the code way less complex. Like we were doing all this extra effort to construct a asynchronous queue and asynchronous methods to insert updates into the queue and async methods to like render the things, um, and having to keep all that here and having to register all our chunks inside a second data structure map so that we can access them later and all this shit. And we don't have to do any of that anymore because we're doing it inside the nodes themselves, which are already in a data structure, so we're not duplicating data. It's just really good, I think. Set camera override, camera override, camera override, camera override. Max updates per frame. I don't think I'm using this anymore, but we may want to eventually. Noise parameters. The tick function. Tick an editor. Okay. I mean, this actually looks pretty clean. Like, our whole planet class is down to 200 lines. Our quadri node is bigger, but okay. So constructor, destructor, on construction, initialize, update, mesh parameters, tick an editor, updates per frame, and node depth, max node depth. Camera position override. Noise parameters, max updates, max updates. Let's cam position. We're just looking for any leftover methods that we're not using anymore. No, this looks pretty clean. So I'm pretty happy with the planet actor here. Let's take a look at our quadri node. I think there's going to be some more stuff that we can clean up here. Yep, that's fine. Split, try merge, update WOD, generate mesh data, initialize chunk collision. So he broke this up into basically four asynchronous methods that kind of daisy chain off each other. So when we invoke this, eventually it's going to invoke this, and then at the end of this, it's going to invoke this. And that lets us do all our chunk initialization and collision initialization on the game thread while not blocking the game thread, which is nice. Parent actor noise gen, yep, that makes sense. ID, face direction center, resolution, sphere radius, node average size, min depth, max depth. I might play around with the resolution here. Half size, quarter size, center on sphere, compare points, initialize, rendered state, render timestamp, updated timestamp. These, I don't think I'm using these anymore. Comment them out. Node sphere bounds, parent, children, mesh data, chunk component. Okay. Let's try upping the resolution and seeing what kind of performance hit we take. And then we should have a couple of errors. We don't need this. We don't need this. All right, let's try it. Um, High resolution go. Wait, there's no way that finished that fast. Oh, it's going pretty fast actually. It's gonna explode, but it did build quickly at least. So yeah, I'm actually really happy with the progress on this. We only have realistically two things left. We need to do oceans, which we could be as simple as like a single layer water material that we figure out how to make it work right with our scene setup, to as complicated as a fast Fourier ocean transform ocean based on the fast Fourier equations. I want to do fast Fourier at some point. I don't know if it's on the near horizon. All right, we're just gonna fuck it. So what we'll probably do is try to get a decent water layer, and then turn our attention to some volumetric clouds, which could even be part of the same HLSL as the atmosphere shader potentially, if we decide to do it with ray marching, which we might. Um, or we could do them. We could figure out some kind of like procedural spawning of VDBs. But yeah, we need clouds. We need water. And then we pretty much have a complete terrestrial planet generator. We would need like things like a lava layer for molten planets and things like that. But this is really coming along. Like, I think our quadtree node didn't grow that much. We're under 1,000 lines in the quadtree node, and I mean 200 of those just about are just in the generate mesh data, which is like just a big block of procedural code basically. Gonna work? Okay, works. Nice. Nice, nice, nice. Okay, let's take a look at the wireframe here. It should be much higher density. Seems to be handling 66 with no problem. Let's see what it looks like. Find an area with some more terrain diversity. It's running just fine at 66. All right, let's have some fun. Quadtree nodes, 66 times 2. Double the resolution. I didn't do the math in my head, but if you add 132, something like that. But yeah, I mean, really just over time, gradually making these components better and better. Eventually, they'll be at a point where they're like good enough to baseline and stop fucking with. And then we'll be working on things like how to walk around on the planet outside of the ship, how to get in and out of the ship. Spherical planet gravity for third person characters is something that is on my radar. Of course, a bunch of different biomes. Okay, there's definitely some lag imparted here with going up a level. We might have locked up. I'm not sure how well it likes me doing resolution changes on the fly. Let's just try running it from scratch. Come on. There it is. I think we found the limit. Okay. I think our threshold in our material is probably a little too high for our slope. Um, I forget what mesh planet. Oh, we have to. Oh, I see. So we turned off material assignment for the moment, so it should. There it is. Okay. There it is. Our number of vertices is too damn high in our resolution for sure. But I think it would be better to go deeper than have a higher resolution at that point, I think. So let's turn this back down to 66. Save it. It's very slow like that. Does look good though. So the nice thing about this is this fixes up the last two bugs in the app, or that I currently have. Which one was the atmosphere bug that I fixed this morning, and the other one was the long-standing bug where we'd have orphan pieces of geometry when moving quickly over the surface. That should not happen anymore since they're being managed by the node's life cycle itself. So that would mean we would have a malformed tree rather than some timing error with our mesh processing queue. And let's go ahead and just save, tear this down, save, start it back up. You find this guy's initialization and usages to, I think that it's possible that part of the WAD stuff that I was talking about might be related to that calculation. So let's take a look at how we utilize that. Yeah, see like this node sphere bounds. Um, should probably be calculated differently. Right now I'm calculating a centroid in generate mesh data, and I think my boundary for the bounds of the node would also be related to that. Delete this because we're not using it anymore. Problem here. Do I do another loop through the vertices? I do. So by this point, yeah, this is okay. This is perfect. So we just want to get um, distance equals max. Um, what is F math max? I was close. We're gonna just equals. How can I get the distance between two vectors? F vector distance. Distance. Vertices I centroid. Max distance and curve distance. All right, so now so before I was doing this calculation to basically try and figure out the bounds here with these compare points, but we don't need that anymore. We should be able to use max distance. Why is it unhappy? T factor double. Oh, yeah. So now we calculate the max distance like this. We should be getting the true max distance, and let's see if that has any impacts on our WOD function. It should. Oops. Okay, let's also do, this is actually really nice. We can do think it does make a difference. It's hard to tell though. Oh, never mind. We weren't actually processing it. Okay. Um, let's go here. Let's set our max step to 10 instead of 9. Let's try 11. Seems to be working better. So rather than doing this like arbitrary calculation that is probably wrong by trying to grab the corner points, we just always calculate the maximum distance from any point to the centroid of the node. We already have to do a loop on the vertices anyway, so it's only adding one more distance calculation to that loop. Okay. And that appears to have fixed the problem I was talking about with it like cascading out too far, which means that we might be able to get a higher resolution now. And we can. Super cool. So that fixes our lot issue, I think. Very nice. Okay, so now when we're right next to the planet, we get like the omega high resolution mesh. Hell yeah, that's sick. All right. Hell yeah. I think it's close, yeah. We should look at this and figure out if there's anything else we can optimize. We have to loop vertices to make triangles. Validate positions. Not using it. That cuts down an entire duplicate array of every point that we have to fill. Um, be able to do it like that. Big easy breakthroughs. That's what I like. Fixing the lot is huge, especially when it's an easy fix. Don't think this is being used. His valid mesh is not needed anymore. This can be cleaned up. But other than like a little bit of cleanup on the LOD helper methods here, like this could be declared as an internal method because it's not used anywhere else. So like, can I just do this? Is this fine? Leave this stuff in for now. If I have a function and it is only called inside the function, way for me to move in. Is the impact on overhead? Okay, then we'll just do, that's fine. What is S used for here? We're gonna get rid of the idea of projecting the location in front of the camera. I mean, it's pretty clean now. I don't really know what else to do. We're down to 466 lines here and 200 lines here. I'm not sure it can get any shorter. Name it something so that somebody who's not a fan of Unleash the Archers can understand it. And we can probably, if we're able to go up higher in our resolution or in our depth, we can probably reduce our resolution to 4 and 12 by default now. All right. Yeah, now we have 12 depth with speed, which is huge. Beautiful. We're not getting the like where like the internal would push out to the edges. So we were doing okay, so that also means we can probably get rid of this. The whole concept of compare points. Coming out the things we want to stop using, that's going to cause it to error out over here. Get rid of all of this. Beautiful. I love deleting code. My favorite thing to do. Right. Get rid of node sphere bounds. Holy shit, that just means that we can get rid of all of this. Beautiful. Chunk out another 15 lines of code or so. See if it works. Oh, I love the fact that we can get rid of all this janky bounds calculation stuff. Use discrete real bounds of the max distance from the node. It's great. Seems to be working without it. And now that we're doing this, I believe, correctly, let's try one more thing. Let's bump up K. Bump up the K volume. Should probably expose this as a parameter. This is like the constant that drives how far it subdivides away from the camera. The higher it is, the further out it will subdivide, I guess is the best way to put it. And I think it wasn't working because of us doing like basically naive bounds calculations for these rather than correctly calculated, which we're doing now. So now what we do is we sum every point in the process of generating it. We average them to get the centroid. And then in our second loop to the vertices where we have to build the triangles, we take the distance of every vertice and we take the max distance that we get out of that. And that should give us our true bounds. And now that that's working properly and not like overflowing with the lower levels when we get close to like before, it would like load in the highest resolution from here to like the far edges of the screen, and that's obviously too much. But if it's working properly, then maybe we can actually have a little bit more distance on our subdivision. All right, come on, come on, come on, come on, come on, come on, come on. Oh yeah, baby. We're in business. In business. We in business now. Oh, it's beautiful. It's fast too. Hell yeah. All right. We're getting close to finalizing this. I mean, I thought it was finalized, but we cleaned up multiple bugs over the past couple days. We can, we might be able to. I have been working bounds calculations in my mesh generation code. Um, take a look, see if you see any opportunities for further optimization, combination of loops, any logical flaws. I mean, that's pretty minor. Oh, this is. I'm logged out. No wonder. Um, that's all pretty minor. Like, we can try pre allocating. I don't think this is going to make a huge difference. All right. Fuck it. So lessons learned here is to always do your bounds and centroid calculations from your actual generated mesh data. Don't try to derive it at the start or anything like that. Do all your mesh displacement first. and then use those values to calculate your needed values. We might be in the land of it becoming pretty realistic to do edge fans too, because like part of the problem with doing edge fans, I mean, we would have always had the ability to do this. It would just been more of a pain in the ass, was finding the neighbors. Um, so our paradigm for mesh, like meshing them together right now, is something called mesh skirts, which is the easiest way to do it, I think, probably. So for each chunk we make, we add an additional ring of vertices around the outer edge. That ring still gets displaced by the noise, but then it gets displaced towards the center point by some amount. So you can see that right here. We have a little skirt, and these overlap with the other meshes since they're one out from its actual bounds, right? So like this is the boundary of these two meshes. You can see this mesh is being displaced downward this way, and this one's being displaced downward this way. So that is how we're doing it currently. This is nice for debugging purposes because we can see each chunk discretely. However, there's another paradigm called edge fans, and what edge fans does is each node checks the, so there's a bunch of different configurations of statically defined vertices that can be generated. Um, and each node checks its neighbors for what resolution the neighbor is at. And then rather than doing this little mesh skirt here um, on the edges of these, instead what it would do is if it's at a boundary between a lower resolution mesh, it changes the actual geometry that it generates for this node to where the very far vertices will line up with the resolution of this mesh, and then on the sides that it's the same resolution, it doesn't have to change it. And what you get then is a seamless grid of what appears to be no seams. It probably blend a little bit better. Like there is the issue with this where if I can find a spot to maybe cause it to happen, let's find some mountains. That's usually easiest to see over the mountains. But like there's sometimes you can see the boundary, right? And that would probably fix that. You wouldn't be able to tell where the individual chunks are as easily anymore though, because it would all be like meshed together. So that's something I'm interested in looking into. But I mean, yeah. So let's keep polishing. Node locked, initialized, current tick, clean interval. We don't need this anymore. We don't have to clean it. Like we were doing all kinds of like janky shit to try and clean up orphaned nodes, but we don't have to worry about that anymore. Max updates per frame, I think will go away probably. It may have to come back if 12 is our defaults here. Okay, so I'm pretty confident in this code at this point. I think I'm going to do one more pass. So we're just going to go line by line through each one. So we've got can never tick, start with tick enabled, true, tick interval at a tenth of a second. We have a destroy function nullifying all our root nodes and invoking super. We have our on construction method that gets the actor transform and invokes super. Um, Sets up some camera override stuff and then invokes initialize planet. We also invoke initialize planet over here in begin play. Um, oh, I see. This is so that it can tick in the editor. This is so that it can tick while we're playing. That makes sense. We get all the children that might exist, and we destroy them. Initialize our noise. Create our nodes. Invoke their generate mesh data method so that they can begin initializing. And then flag our planet as initialized. Day one. I mean, this seems fine. We could also dethrottle this. Feel like it's not super intuitive that it would work that way, so I'm going to try commenting it out now that we've fixed some of the other performance problems and see if it's fast enough. We'll just assume it is. If we have to come back and do some throttling, we can. I think it's running pretty quick now, though. Formatting, ADD plus OCD, last camera position, last camera rotation, camera FOV, camera override state. We're not using that, so let's get rid of it. Man, I just love how simple this is. It's great. Alright, so we're going to downsize them, or we're going to collapse them as we have reviewed them. Collapse, 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 noise parameters, yep, collapse it. We don't need to do this anymore. And I don't think we ever did, it was just an experiment. Seems pretty fucking clean. collapse, tick actor, collapse, and should take it in viewport only. Collapse. Okay. Beautiful. That's a clean pointed actor right there. All right. So next, these don't need to be set right here. They're set in the planet actor. Now there are probably still quite a few. There are still probably quite a few things that I could get rid of in here. Like I don't think I'm using like the leaf collection anymore. I guess I couldn't do it. Interesting. No references. Not being used. Do this like this. Alright, now we just need to do one more pass, I think, here, stepping through each method. Constructor is a nice, beautiful, clean constructor. No problemo. Destructor is also clean. Curse collect leaves, I don't think has got any references anymore. Curse update LOD is used. S and calculate final point and try set LOD are all used. Update LOD is also used. Maybe. Oh, I see. This is the wrapper. Yeah. Okay, that makes sense. Alright, nothing to review there. Nothing to review there. Check. Sure. That's just from whatever paper I pulled this from. Final distance, try set LOD, update LOD, split. Alright, so we tree structure walk. If it's not a leaf, we return. Our operating ID is the ID of this node. Our operating level is this depth. We check the children. If it's already split, we don't have to do anything. If it's not, we split it. We construct it. Merge and try merge look fine. Leave our commented out logs, although it should probably move this. We do want to leave the commented out logs in here in case we ever need them. Is leaf, easy, depth, easy. This seems to be working just fine. You know, for a long time I was all about writing like comments on everything, but I've kind of come around to the idea that like you don't really need comments. Like the code should be written in a way where you can understand it without comments. And if you can't, the best way I've seen it put is like if you're working on something and you can't understand the code without the comments, then you probably shouldn't be working on that thing. And then it's just generate mesh data. All right. Seems pretty clean. We could go back here and add some logging. $397 lines. We're under 400. So we're now under 600 lines total for the whole thing, which is beautiful. Like the less lines the better. I love deleting code. I love obliterating things that I spent hours working on. It's great. It's the best part of being a software engineer is deleting your own shit when you find a better way to do it. Okay, save it, save it, save it, save it, build it. Yep, it's working good now. Still a little bit of lag if you rush in too fast, but we have our speed influence zone to kind of control that for the actual gameplay. So it's really only a problem in the editor if you're like zooming, right? Because like if I were to hop in my spaceship and go to that same point, it's not going to be a problem. Like the load times, that is. So clouds, water, foliage, still to go, and probably more work on materials as well. Right now we're just using flat colors, but it could probably be better. All right, do I crash into it? I do. Full working collision is huge as well. So changing the rendering pipeline of this paradigm made our collision work properly, even at high speed, which is really nice. Because formerly, if you've been watching my videos, we clip through the landscape at high speeds, but we don't do that anymore. We just crash, which is how we want it to be. Can I just clip just the wing? Yes, I can. Yeah, you can see the divide. You could see the dividing line there for a second, which I think mesh fans would fix. It's very minor. The fact that we're at 12 depth and running well is incredible. Um, it's huge. It means that we could probably go even deeper. But yeah, pretty psyched about that. Moves along 1.8 km per second, 1.9, 0.95. Can we break 2? I think 2 might be the actual limit that I have set. If I was to just like stop paying attention for a second and skim the ground at high speed, we should get collision. Yep, we got it. All right, so we have full collision. We have uh, no errors. We have proper cleanup. We don't have holes appearing. We have high speed and high depth potential. We fixed that the issue with the big one was fixing the issue with the LOD, and we cleaned up all the code. This is great. Huge, huge progress in a short amount of time. Okay, now hopefully everything still works. And if so, I'm gonna hop up, go walk my dogs, get some lunch, probably play some video games. We made huge progress on this. Huge. Big time advancements in tech here. Seems to be working just fine. Beautiful. All right, great. Save it, close it. We're good. All right. Later.